Next heading collision. Next heading collision. When two bodies are approaches. When two bodies are approaches are approaching each other, a force comes into play. A force comes into play. A force comes into play between them for a finite time. And brings about a miserable change in their velocities. Momenta and energy according to respective laws of conservation. A collision is said to have taken place. A collision is said to have taken place. Okay. When two bodies are approaching each other, a force comes into play. Okay, between them for a finite time. When two bodies are approaching each other, a force comes into play between them for a finite time and brings about a measurable change in their velocities, momenta and energy according to the respective law of conservation. A collision is said to have taken place. Okay, a collision is said to have taken place. Okay, during collision, the force some interaction comes into play between the two colliding particles. Okay, it should, however, be clearly understand that in physics, collision does not necessarily mean physical contact between the two bodies. Okay, it should, however, be clearly understood that in physics, collision does not necessarily mean physics contact between two bodies. Okay, during collision, the force of some interaction comes into play between the two colliding particles. During collision, the force of some interaction. During collision, the force of some interaction comes into play between the two colliding particle or system for a finite small time, which bring about a change in their relative motions. If the collision acts for a time t naught to t naught plus delta t, then a time t less than time t less than delta t is known as time before collision, is known as time before collision. Okay, time before collision. Okay, time before collision. And time t greater than time t greater than t0 plus delta t is called time after collision. Is called time after collision. Time after collision. Okay. The collision is termed scattering if the nature of particles does not change after collision. The collision is termed scattering if the nature of particles does not change. If the nature of particles does not change after collision. Okay. The collision is termed scattering if the nature of particles does not change after collision. Okay. Familiar examples of collision or scattering are the deflection of a comet as it passes near the solar system, and the deflection of an alpha particles by an atomic nucleus. The study of collision is of particular importance in atomic and nuclear physics. The bodies involved may be atoms, nuclei, or various elementary particles such as electrons, protons, etc. There are two types of collision. There are two types of collision. There are two types of collision. First is elastic collision. Elastic collision. And the second is inelastic collision. Inelastic collision. Okay. Inelastic collision. Okay. First, elastic collision. Okay. Elastic collision. A collision in bracket is scattering. A collision is scattering. A collision is said to be an elastic. A collision is said to be an elastic collision. An elastic collision when the final particles after collision after collision are the same as the initial particles before collision. As the initial particles before the collision. Okay. Second number. Elastic collision. A collision is said to be an elastic when collision the final particles after collision are the same as the initial particles before the collision. That means the nature of The nature of final particles cannot be changed after the collision of initial particles. Okay. Second, the sum of the kinetic energy. The sum of the kinetic energy. The sum of the kinetic energies of the particles after collision of the particle after collision of the particles after collision. The sum of the kinetic energy of the particles after collision is the same as the kinetic energies of the particles before collision. Kinetic energy of the particles before collision. Okay. The sum of the kinetic energy of the particles after collision is the same as the kinetic energy of the particles before collision. That means kinetic energy, sum of, okay? Sum of kinetic energy, sum of kinetic energy. Sum of the kinetic energy of a particle after collision equal to the sum of kinetic energy of the particles before collision, then the collision is elastic collision. Next is inelastic collision. Second number is inelastic collision. Second number inelastic collision. Okay. Inelastic collision. Elastic scattering. This is also known as elastic scattering and inelastic collision. That means inelastic scattering. Inelastic scattering. Okay. A collision is said to be an inelastic collision. A collision is said to be an inelastic collision if the first point, final particles after collision, the final particles after collision, final particles after collision are the same as the initial particles before collision. The final particles after collision are the same. The final particles after collision are the same as the initial particles before collision. As the initial particles before collision collision. Okay, and second is one minute, and second is second, the sum of the kinetic energies, the sum of the kinetic energy of the particles after collision is either more or less, than the sum of kinetic energy of the particles before collision, before collision. Okay, before collision. Okay, the sum of the kinetic energy of the particles after collision is either more or less than the sum of kinetic energy of the particles before collision. Okay, a collision is said to be perfectly inelastic if the particles stick permanently together and impact and loss of kinetic energy is maximum, consistent with the law of conservation of momentum. A collision is said to be perfectly perfectly if the particles perfectly inelastic if the particles stick permanently together and impact and the loss of kinetic energy, is maximum, consistent with the law of conservation of momentum. The law of conservation of momentum. Okay. Next is conservation of linear momentum. Conservation of linear momentum. Conservation of linear momentum. Consider two particles of masses m1 and m2. m1 and m2. Okay, moving with velocities u1 vector and u2 vector. Okay. Consider two particles of masses m1 and m2 moving with velocity u1 and u2 respectively before collision in an inertial frame of reference. After collision, their velocities becomes v1 and v2 vector, v1 and v2 vector. Okay, this is a before collision. This is before collision, before collision, before collision. Okay, collision, and after collision, collision is converted into v1 vector and v2 vector. Velocity is change in v1 vector and v2 vector respectively when no external force acts on the particles. When no external force act on the particles, their total linear momentum is conserved. Their total linear momentum is conserved. Okay, the linear momentum is conserved. So m1 e1 vector plus m2 u2 vector equal to m1 v1 vector plus m2 v2 vector. Okay, m2 v2 vector. This relation holds good both for the elastic as well as inelastic collision. Okay, this relation holds good. This relation holds good both for elastic and elastic as well as inelastic collision. Okay, conservation of kinetic energy. Next is conservation of kinetic energy. In the case of an elastic collision, the kinetic energy is also conserved. In the case of an elastic collision, the kinetic energy is also conserved. Okay, in the case of an elastic collision, kinetic energy is also conserved. So 1/2 m1 e1 square plus 1/2 m2 e2 square equal to 1/2 m1 v1 square plus 1/2 m2 v2 square. 1/2 m2 v2 square. Example of elastic collision. Examples of elastic collision. Okay, examples of elastic collision. Collision between molecules or gases according to kinetic theory. Okay, collision between molecules of gases according to kinetic energy theory. Okay, kinetic energy theory. Second point, collision between atoms and nuclei and collision between atoms and nuclei. Collision between particles like electrons, proton, alpha particle, etc. Collision between atoms and nuclei. Okay, third points, collision between particles collision between particles, collision between particles, collision between particles like electron, protons, alpha particles, etc. Examples of elastic collision according to kinetic theory. Collision between nucleus of gases according to kinetic theory. Second point, collision between atoms and nuclei. Third point, collision between particles like electron, protons and alpha particles. Two types of inelastic collision. Okay. Two types of inelastic collision. Okay. Inelastic collision. Two types of inelastic collision. In case of inelastic collision, in the case of inelastic collision, there may be an increase or decrease. There may be an increase or decrease of kinetic energy, giving rise to two types of inelastic collision. Inelastic collision. First is endoergic. Okay, first is endoergic, and second is exoergic. Okay. The collision between particles like electron, proton and alpha particles. Two types of inelastic collision. In the case of inelastic collision, there may be an increase or decrease of kinetic energy, giving rise to two types of inelastic collision: endoergic and exoergic. Okay. Endoergic collision. First is endoergic collision. Okay. 1 minute. First is endoergic collision. Okay. 1 minute. First is endoergic collision. Endoergic collision. Okay. For bodies of microscopic size. Okay. Macroscopic. Okay. This for bodies of macroscopic size. Endoergic collision. Okay. Endoergic collision. For bodies of macroscopic size, the loss of kinetic energy. The loss of kinetic energy occurs as heat. Sound, etc. But in the case of atoms, case of atom. But in the case of atom molecules, but of case in the atom molecules, etc., the atoms may observe may observe a part of the kinetic energy and move into an excited state. Kinetic energy of the particles. The kinetic energy of the particles. The kinetic energy of the particles is then reduced, and we have 1/2 m1 e1 square plus 1/2 m2 u2 square equal to 1/2 m1 v1 square plus 1/2 m2 v2 square. 1/2 m2 v2 square. Okay, v2 square plus e. Okay, where e is the excitation energy. Okay, such a collision in which the kinetic energy of the final particle is less than the kinetic energy of the initial particles is known as endoergic collision. Okay, such that the kinetic energy of the final particles, kinetic energy of the final particle, kinetic energy of the final particles is less than the kinetic energy of the initial particles If the kinetic energy of final particles is less than the kinetic energy of the initial particles is known as endoergic collision. Okay, endoergic collision. Exoergic collision. Okay, exoergic collision. If, however, the atoms are already in the excited state and after collision come down to the normal state. If however, the atoms are already in the excited state and after collision come down to the normal state, come down to the normal state. The excitation energy adds up to the final kinetic energy, and we have 1/2 m1 e1 square plus 1/2 m2 u2 square plus e equal to 1/2 m1 v1 square plus 1/2 m2 v2 square. Okay, such a collision in which the kinetic energy of the final particles such in which the kinetic energy of the final particles, kinetic energy of the final particles, kinetic energy of the final particles is more. Kinetic energy of the final particles is more than the kinetic energy of the initial particles. Initial particles is known as exothermic. Exothermic. Exoergic collision. Okay. Thank you. Reaction. Okay. Reaction. First, the final particle after collision. The final particle after collision known as products. Okay, are entirely different from the initial particles known as reactants before collision. Reactants before collision. Okay. Collision. The final particle after collision known as products are entirely different from the initial particle known as reactants before collision. Okay. Second point. The sum of the kinetic energy of all particles after collision. Kinetic energy of all particles after collision is different from the sum of the kinetic energy of the particles before collision. Kinetic energy of the particles before collision. Okay. Sum of the kinetic energy of all particles after collision is different from the sum of the kinetic energy of the particles before collision. Okay. In all the above cases, the law of conservation of linear momentum and the law of conservation of angular momentum holds good. It is because in each case the interacting particles being isolated. Okay. And no external charge acts on the system. Okay. Another point to be carefully noted. Another point to be carefully noted is that in the case of inelastic collision and reactions, only the sum of the kinetic energy after collision is different from the sum of the kinetic energy before collision, but the total energy of the system, including kinetic energy, potential energy, and any other form of energy remains conserved. Okay. Advantage of studying collision process. Advantages of studying collision process. Okay. Collision process. Advantages of studying collision process. Okay, 1 minute. Advantages of studying collision process. Okay, various types of interaction and forces are various type of interaction, various type of interaction, various type of interactions and forces are operating in nature, at microscopic as well as macroscopic, levels. Okay, various type of interaction and forces are operating in the nature at microscopic as well as macroscopic levels. Okay, a study of closing process or relative motion between the two interacting particles help us to understand before the basis, nature and characteristics of this interaction and forces. This is done by measuring the initial and final energy and linear as well as angular momentum of the participating particles in accordance with the law of conservation of energy and momentum. Okay, the deflection of the path of a comet passing, the deflection of the path of the comet, passing near the solar system, passing near the solar system, and the elliptic path of planets within the solar system helps us to understand the nature of gravitational forces. Okay, forces. The deflection of the path of the comet passing near the solar system and the elliptic path of the planet within the solar system helps us to understand the nature of gravitational forces. Okay? Collision between molecules of gases according to kinetic leads to understanding of interatomic and internuclear forces. Okay? Collision between molecules of gases according to kinetic theory leads to understanding of interatomic interatomic and intermolecular forces. Atomic and intermolecular forces. Collision between molecules of gases according to kinetic theory leads to understanding of interatomic and intermolecular forces. Okay. Next, scattering of alpha particles in Rutherford scattering. Okay. Scattering of alpha particles. Scattering of alpha particles in Rutherford scattering. Scattering of high energy photons. Scattering of high energy scattering of high energy comptons energy in compton scattering nuclear reactions involving high energy electrons, protons, neutrons, deuterons and alpha particles scattering of slow neutron scattering of slow neutrons by nuclei and emission of alpha and beta and emission of alpha and beta particles from radioactive nuclei help us to understand the nature of nuclear forces, properties of the nucleus, and atomic structure. Okay. Scattering of alpha particles in Rutherford scattering. Okay. Scattering of high energy photons in compton scattering nuclear reactions involving high energy electrons, protons, neutrons, deuterons and alpha particles. Scattering of slow neutrons by nuclei and emission of alpha and beta particles from radioactive nuclei help us to understand the nature of nuclear forces, properties of the nucleus and atomic structure. Okay, thank you. Next study is the laboratory and center of mass of frames of reference. Okay, good.